Now to throw your own error, you can use the throw keyword. And there is a class in Dart, the exception class, which you can use to build your own exception. However, the Dart team discourages that you directly use that. Instead, you should build your own exception based on that exception class here. For that, let me add a new folder, the models folder. We saw that before in this course. And in there, I'll add a http_exception.dart file. And you can name this however you want, of course. I'll add a class here, and I want to name it http exception, because in the end, I'll throw that exception when we have some problems with our HTTP requests. Now, this is a class, and exception classes, which you plan on throwing, should do something which we haven't done before. They should implement exception. Now, what does implements mean? We saw with, we saw extends. What's implements? Implements uses a class. Exception here is a class. It's an abstract class, though. Abstract means we can't directly instantiate this. And in the end, when we implement a class, we are signing a contract. We're forced to implement all functions this class has. Now, exception itself has no class, but in the end, this is just some complex syntax for saying the exception class essentially looks like this. And there we have a toString method. Now, actually, every class in Dart has a toString method automatically, because every class invisibly extends object. Object is the base class in Dart, which every object is based on. So toString is a method you can always call on any object. For example, here on this exception here, we can call toString on our own product here, on the existing product I have here. I can call toString, even though we never added that, because toString is available on every class. But now we're signing a contract that will override this, because normally toString for your own classes just prints this instance of HTTP exception thing. So it just tells you of which type of class your object is. Here, however, we want to instead print the error message, because exceptions typically store a message. So here I'll add a final string message and a constructor to set this error message. And then here I'll override toString with @override to make it really clear that I'm adding this deliberately. And instead of returning super toString, which would yield us this instance of HTTP exception thing, instead of doing this, I will return my custom string, and here I want to return message. So my own HTTP exception class is now configured to always print the message here when we call our exception, which would be a concrete instance of this class, toString, or when we do print our exception. In all these cases, it will trigger toString, and now it will simply print that message. So with that, we have our own exception class added. Back in products, we can now throw our own exception class. So let's use HTTP exception here. And for that, of course, add an import to our own class here from the models folder from the HTTP exception Dart file. With that import added, I'm throwing my own HTTP exception, add a message here, could not delete product, something like this. I'm never using that message here in this program, but you could use it anywhere if you want to. And now with that, we're throwing that. Since I throw in then, we should now make it into catch error, and therefore now we should restore that. So if we try that again, and I delete this, it's gone, and it's back. It's gone, and it's back. Because now we're really using that optimistic updating here. Now we can also take this to the next level and even add some error handling. And now actually, to always use the same syntax, I will now add async await. We wouldn't have to do that here, but I don't want to mix the different future syntaxes. So here I use async, hence we get back a future, and therefore now I await here, and hence I get my response here and store this in this final constant. In the next line, I then check this and I throw an error if we have a problem. Now let's just clean this all up correctly. So here I check if we have a problem with the status code. If we do, I can already do the rollback in here, of course, because that's in the end what I had in catch before. Else, if we have no problem, And actually, we will only reach that if we're not making it in here, because if we make it in here, throw is basically like return, and it cancels the function execution. The other code will not execute. So if we don't make it in here, then this code will run, and we do reset the product. Now, since I'm not using a promise with then and catch anymore, however, I should execute this, of course, to have optimistic updating before we actually start sending the request before we wait. So otherwise, we would wait for the request to finish before we delete this. I want to delete it before the response is there. And now we have a setup where we immediately delete, then we wait for the response, then we check the response and possibly roll back and throw an error if it is an error response, and otherwise we just reset that existing product which we cached. And now we can actually handle that error in the user products screen, there in the user product item. When we delete here, this now may fail, so we can now wrap this with try catch here and catch a potential error we might be getting. For that, let's just turn this into an async function here so that this can work with this future, which this is behind the scenes. And then here in catch, we could show a snack bar, for example, if we wanted to. So there we could use scaffold of context, show snack bar. You learned about that in the user interaction module, to create a new snack bar, and there show a content of deleting failed, for example. And content, of course, takes a widget, so let's use a text widget there. So with that, I'm just showing that extra information. Besides restoring the data, I now also give the user some visual feedback that this failed. And of course, now we also have to await here, otherwise we'll not handle this appropriately. So now with async await and try catch here in user product item, we should now see a scaffold. If we reload here, if we delete this and it's re-added. However, there is no snack bar. And we got an error here that's causing this, or that's explaining this behavior. Basically, the problem here is with scaffold off, I'm doing this here inside of a future, right? I'm doing this here inside of a future because async is used here, and therefore everything in there is wrapped into a future. And therefore, off context can't actually be resolved anymore due to how Flutter works internally. It's already updating the widget tree at this point of time, and therefore it's not sure whether a context still refers to the same context it did before. Solution for that is to go to the build method and get our scaffold here, store that in a constant variable with scaffold of context, and then down there I just use this scaffold variable instead of refetching access. If I do that and I now delete this, now you see this works, and now we have deleting failed here at the bottom. So now it's showing that scaffold works because now we're getting access to that scaffold outside of our future here earlier when we built this already. And therefore, we already have access to our scaffold no matter if this rebuilds or not. And hence, we can now use that down there. Now let me also align the text here with text align.center. Just a tiny improvement, which I like to have here. But with that, we have a decent setup, I'd say. And we give the user some feedback, and we have some optimistic updating in place. And of course, we're also now able to delete our products if I fix this error and I add JSON again. So let me demonstrate this as well, because of course that is also not that unimportant. Yeah, now it's gone and it stays gone. And even if I reload, it's still gone.